This video is for section 1-5, identity and inverse elements. First, let's discuss the axiom of zero. The set of real numbers contains an element 0 having the property, if you add 0 to any real number, you get that same real number. You get a number identical to what you had to begin with. Therefore, 0 is called the identity element. So on the blank, fill in 0. 0 is the identity element for addition. It is the only number you can add to something and not change its value. Next, additive inverse. The additive inverse of a number A is the negative of A, or you might say the opposite of A. Another word for additive inverse is opposite. Here are some examples. What is the additive inverse of positive 14? It's negative 14. What is the additive inverse of negative 3? It's positive 3. What is the opposite, which means the same thing as additive inverse, of positive 2x? It's negative 2x. Next, the axiom of additive inverses, an assumption that is made about additive inverses. If A is any real number, there is a unique real number, the negative of A, such that when you add them together, you get 0. So this axiom is saying if you add opposites together, you always get 0. Next, let's define absolute value of a real number. The symbol for absolute value are these vertical lines surrounding a number. So this right here is red, the absolute value of A. Absolute value is defined as being equal to the greater of the two numbers A and negative A. For example, if A is the number 8, what's greater, 8 or negative 8? Whichever of these is greater, that's what the absolute value of 8 is. Or let's say that A is the number negative 2. What's greater, negative 2 or its opposite, 2? Whichever of these is the greater number, that's what the absolute value of negative 2 is equal to. The absolute value of 0 is defined to be 0. Another way to think of absolute value is that it is the non-negative distance from a number to 0 on a number line. For example, question A, what is the absolute value of negative 6? What is the non-negative distance from negative 6 to reach 0? How many units is that on a number line? It's 6 units. What's the absolute value of 13? What is the non-negative distance between 13 and 0? It's 13 units. Or question C, what is the absolute value of 3 minus 7? First, evaluate what's in those vertical lines. 3 subtract 7 is negative 4. Then do the absolute value. The answer turns out to be 4. Next, let's discuss what real number is called the identity element for multiplication. What number can you multiply something by and get an answer identical to what you start with? That number is 1. 1 is called the identity element for multiplying. Next, the axiom of 1. The set of real numbers contains a unique number, 1, having the property that any number times 1 is equal to that same number. Next, let's define multiplicative inverse. The multiplicative inverse of any number A is 1 divided by A. Another word for multiplicative inverse is reciprocal. So in Algebra 1, you may have used the words multiplicative inverse, or maybe you used the word reciprocal. Here are some examples. What is the reciprocal of 1/2? Well, what is 1 divided by 1/2? It's 2. What is the reciprocal of 6? That's 1 divided by 6, or 1/6? Creating reciprocals is very straightforward. You take a number and interchange the numerator and denominator. You flip it upside down. Next, the axiom of multiplicative inverses, something that is assumed to be true about reciprocals. If A is any non-zero number, there is a unique number, the reciprocal of A, such that when you multiply them together, you get the answer 1. For example, let's say A is 3. The reciprocal of 3 is 1/3. When you multiply these together, you get 1. Next, the multiplicative property of 0. If A is any real number, then multiplying that by 0 makes the answer 0. 0 times any number equals 0. Next, the property of the reciprocal of a product. If A and B are non-zero real numbers, then the reciprocal of their product, this should say product here. Will you cross out that S? The reciprocal of their product is the product of their reciprocals. Let's translate that into symbols. The reciprocal of the product of A and B would be 1 over the product A times B. We're told that that's equal to the product of their reciprocals. So 1 over A times 1 over B. It's this assumption that allows us to multiply fractions, which we'll do later in class. Here's an example. Use that property to rewrite 1 over 3 times 7. This is equivalent to 1 over 3 times 1 over 7. Next, the property of the negative of a sum. If A and B are real numbers, then the negative of their sum is the sum of their negatives. Let's translate that one into symbols. The negative of their sum. So the negative of the sum of A and B. That looks like that in symbols. We're told that that's equal to the sum of their negatives. So negative A plus negative B. This is a critical assumption to make as well, because this is what allows us to add negative numbers later in the class. And here's an example of that. The negative of 2 plus 3 is the same thing as negative 2 plus negative 3. So you can see that later in class when we start to add negative numbers together, that the way that it is done is to rewrite it as the negative of 2 plus 3, which we can then find out is negative 5. Let's summarize the lesson. We discussed several more assumptions that are made about real numbers, which will allow us to do algebra later this year. Some of them included the special properties of 1 and 0. Another involved fractions, and the last involved negative numbers.